from LJIET Institute of Engineering and Technology. Today's session we are going to discuss about Fourier series. Let's move to our class. In earlier lecture we are already discussed about Fourier series, definition of Fourier series and two examples of Fourier series. Let's start with one more example in terms of exponential function. Find the Fourier series of function f of x equal to e raised to minus x, where interval is 0 to 2 pi. Then first of all we find Fourier coefficient. Then a0 equal to 1 upon pi integral. Actually range of interval is c to c plus 2 pi, but here value of c is 0. That is our initial value. Then 0 to 2 pi f of x dx. Here function that is exponential function e raised to minus x, then 1 upon pi 0 to 2 pi e raised to minus x dx. Then integral of this term, then we get e raised to minus x by minus 1 0 to 2 pi, upper limit minus lower limit, then minus 1 upon pi e raised to minus 2 pi e raised to 0 1, then minus comes inside the brackets, then 1 minus e raised to minus 2 pi by pi. That is the value of a0. Now next Fourier coefficient is an, then 1 upon pi integral 0 to 2 pi f of x cos nx dx. Then substitute the values of function, that is our exponential function cos nx dx. In this formula we cannot go for Bernoulli's equations. So you already learned in 11th science integral e raised to ax cos bx dx, then e raised to ax upon a square plus b square, a cos bx plus b sin bx. We use variable exponential into cos as well as exponential into sine. Then we cannot go for integrating by parts as well as Bernoulli's equation. We must use this formula to solving the exponential function type of examples. Then here value of a equal to minus 1 and b equal to n. Then substitute the values of a and b in this equation. Then we get e raised to minus x, a square plus b square, a cos bx plus b sin bx. Limit which is 0 to 2 pi. Then upper limit minus lower limit. Then upper limit, that is 2 pi. And e raised to minus 2 pi 1 plus n square. Here cos 2n pi plus sin n pi 0 minus e raised to 0 1 plus n square cos 0 sin 0 0 0 into anything 0. Value of cos 2n pi, that is 1, and sin 2n pi, that is 0. Cos 0 1, sin 0 0. Then e raised to minus 2 pi 1 plus n square, that is minus 1, then minus plus cos 0 1 e raised to 0 1, then 1 upon 1 plus n square. Then denominator which is common, then taking LCM, then we get, that is the value of an. Similarly we can find value of Bn. Then 1 upon pi integral 0 to 2 pi f of x sin nx dx. Then substitute c value means function, that is e raised to minus x sin nx dx. Now similarly we have another formula, integral e raised to ax sin nx dx. Then e raised to x upon a square plus b square, a sin bx minus b cos bx. Then compare this equation to this formula. Then here a equal to again minus 1 and b equal to n. Substitute the values of a and b in this equation. Then we get e raised to minus x 1 plus n square, a minus sin nx minus n cos nx. Here range of integral, that is 0 to 2 pi. Then upper limit minus lower limit. Then substitute the x as a 2 pi. Then e raised to minus 2 pi 1 plus n square sin 2n pi, that is 0, cos 2n pi, that is 1, minus e raised to 0 1, then 1 upon 1 plus n square sin 0 0, cos 0 1. Now simplify this term. Then minus n e raised to minus 2 pi 1 plus n square, minus minus plus n upon 1 plus n square. Now taking LCM and n which is common, then we get 1 minus e raised to minus 2 pi upon 1 plus n square. That is value of Vn. Now substituting the values of a0, an and bn in our formula of Fourier series, then f of x equal to a0 by 2 summation n equal to 1 to infinite an cos nx plus bn sin nx. Just substitute the values of a0, an and bn. Then a0 equal to 1 minus e raised to minus 2 pi by 2 pi plus summation n equal to 1 to infinite value of a, that is 1 minus e raised to minus 2 pi upon 1 plus n square cos nx plus n 1 minus e raised to minus 2 pi by 1 plus n square into sin nx. That is our Fourier series. Next counter example is next example is series of f of x equal to minus pi x interval of x, that is minus pi to 0, 0 to pi. Also deduce that summation n equal to 1 to infinite 1 upon 2n minus 1 whole square equal to part square by a. First for this type of example, we can say that discontinuous function. How we can say that discontinuous function means here above example we have range of interval is 0 to 2 pi fixed. A function that is only one function, e raised to x, x square, whatever, but function has a value fixed. But here we have more than one functions in particular interval, means 0, we have a function as a minus pi, and 0 to pi function value as a x. That at particular 0 position we can say that our function is discontinuous. In this type of example, from value of function at 0 position we will find. And first finding Fourier series with the help of formula. First formula of a0, that is 1 upon pi, interval is minus pi to pi, total limit minus pi to pi, f of x dx. Now, but we have function, value of function is minus pi, at particular range minus pi to 0, means we will break the limits. Then first limit is minus pi to 0, function value is minus pi plus 0 to pi, function value is x dx. Means this type of example we must be break the limit of integration and solve the examples. Now we apply the integral, and minus pi into x, here minus pi to 0, plus x square pi to here 0 to pi. Then upper limit minus lower limit, then 1 upon pi 0, then 0 into anything 0. This is the limit of lower limit, sign of lower limit, then minus pi into minus pi plus here pi square by 2 minus 0. This upper limit minus lower limit, 1 upon pi minus minus plus again minus, and minus pi square plus pi square by 2, taking LCM, then 1 upon pi minus 2 pi square plus pi square by 2, then we get minus pi by 2, that is value of a0. Similarly, we will find value of an, then an equal to 1 upon pi integral minus pi to pi f of x cos nx dx. Similarly, we will break the limits of function, means at this limit means minus pi to 0, function having value minus pi, then minus pi to 0, here minus pi into cos nx dx, plus 0 to pi, function having value x, then x into cos nx dx, then 1 upon pi integral of first term, that is minus pi integral of cos, that is sin nx pi, and minus pi to 0. Then here we apply LJIET, is according to the LJIET, x that is indicated by u, cos that is indicated by v, then we apply Bernoulli's equation. Then in Bernoulli's equation, u as it is integral of v, that is sin nx by n, minus derivative of this, that is 1, integral of this term, that is minus cos nx upon n square, here limit that is 0 to pi, then upper limit minus lower limit 1 upon pi, as it is sin 0 0, cos 0 1, sin 0 0, cos 0 1, sin n pi 0, sin n pi 0, cos n pi minus 1 raised to n, cos of minus theta equal to cos theta, and sin of minus theta equal to minus sin theta. That is an even and odd function. Cos is an even function and sin is an odd function, which is you all are already learned in earlier standard in 11-12 science. Now sin 0 0, 0 into anything 0, minus sin n pi means sin of minus n pi, then we get sin of minus n pi, then we get minus sin n pi, but value of sin n pi is 0, then 0 into anything 0, plus here pi sin n pi 0 minus minus plus cos n pi minus 1 raised to n upon n square, here 0 to pi, sorry, that is our upper limit minus lower limit 0 into anything 0 minus minus plus cos 0 1, then 1 upon n square, then we get 1 upon pi minus 1 raised to n upon n square minus 1 upon n square. Then here taking LCM, then we get pi into s square. That is the value of an. Similarly, we can find bn. Then bn equal to 1 upon pi minus pi to pi f of x sin nx dx. Then similarly, we break the limit here minus pi to 0, then value of minus pi to 0 function having value minus pi into sin nx dx plus 0 to 5 function having value x into sin nx dx. Now taking integral, then 1 upon pi minus pi, here minus cos nx upon n minus pi to 0 plus here that is value of u, that is value of v. Then we apply Bernoulli's equation, then u as it is, integral of v means minus cos nx upon n minus 1, derivative of u, integral of v, then sin nx upon n square, here 0 to pi, then upper limit minus lower limit, then minus minus plus here pi cos 0 1, then 1 upon n minus cos of, that is minus of lower limit, cos of minus theta cos theta, then cos of n pi minus 1 raised to n upon n plus here minus pi cos n pi minus 1 raised to n upon n minus minus plus sin n pi 0, here 0 into anything 0, lower limit minus sin 0 0, then we get 1 upon pi, here pi which is common, then cancel out, then 1 upon n minus 1 raised to n upon n, again minus 1 raised to n upon n which is also common, then we get 1 minus twice minus 1 raised to n upon n, that is value of bn. Now substituting the values of a0, an and bn in formula of Fourier series. Well, Fourier series is then f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos nx plus bn sin nx. What is value of a0? That is minus pi by 2. Then here we substitute minus pi by 4 plus summation n equal to 1 to infinite. Value of an, that is minus 1 raised to n minus 1 upon pi n square into cos nx plus value of bn, that is 1 minus twice minus 1 raised to n into sin nx. That is our equation number 8. Just substitute values of a0, an and bn. That is a0 equal to minus pi by 2, then minus pi by 4. Value of an, that is minus 1 raised to minus 1 upon pi square cos nx. Value of bn, that is 1 minus 2 minus 1 raised to n upon n into sin nx. Here we get just Fourier series. In this example, we have also deduced them, term of deduced them. Then we go for solving the deduced that portion. Then how we will find the reduced z portion? Then according to the function, we can say that our function is discontinuous at particular position. Means that position is 0 because our function is minus pi or x. Here minus pi less than x less than 0, 0 less than x less than pi. Means this 0 position value of function is changed. Means state of function which is changed. Means we can say that our function is discontinuous at position 0. Then given function is discontinuous at x equal to 0, then we will find the value of function at 0 position. Then f of 0 equal to limit x tends to 0 minus f of x plus limit x tends to 0 plus f of x divided 1/2. Means average of two functions. 0 minus means whatever the value after the 0 and whatever the value before the 0 and average that particular term. Then we get 1/2. 0 minus, then we have value minus pi plus 0 plus function having value 0 x, then substitute the x as a 0, then 0 0, then here we get 0, then minus pi by 2, that is the value of f of 0. Now put the x equal to 0 in equation number A. Then we get here f of x, then f of 0 equal to minus pi by 4 plus summation n equal to 1 to infinite minus 1 raised to n minus 1 upon pi n square. Here cos 0 plus sin 0, 0, 0 into anything 0. Then value of f of 0, that is minus pi by 2. Then minus pi by 2, this term comes this side. Then we get pi by 4. Summation n equal to 1 to infinite minus 1 raised to n minus 1 upon pi n square cos 0 1. Now here we can say that we get minus pi by 4. Then summation n equal to 1 to infinite minus 1 raised to n minus 1 divided by pi n square. This pi comes this side, then we get minus pi square by 4. Summation n equal to 1 to infinite. Here we get 1 upon n square into minus 1 raised to n minus 1. In this equation, substitute the values of n equal to 1, n equal to 2, n equal to 3, and so on. Then here we get minus pi square by 4. Then n equal to 1, then we get 1 upon 1 square. N equal to 1, then minus 1, then we get minus 2. Plus n equal to 2, then we get 1 upon 2 square. Minus 1 whole square, that is 1 minus 1, that is 0. Then 0 into everything 0. Then we get similarly n equal to 3, then we get 1 upon 3 square into minus 2 plus, here we substitute 3, then minus 1, then minus 2, then again 0, plus 1 upon 5 square, minus 2, and so on. And in this series, here minus pi square by 4, here minus 2 which is common, then 1 upon 1 square, plus 1 upon 3 square, plus 1 upon 5 square, and so on. Minus minus cancel. This comes inside. The pi square by 8, 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, and so on. Then in this series in generalized form, we can say that summation n equal to 1 to infinite 1 upon 2n minus 1 whole square. If you have any doubts regarding this topic, then feel free contact me. Thank you so much for listening.